Welcome back to this module on water and energy management for Smart City, and congratulations for completing Units 1 and 2. This module was developed by Associate Professor Dr. Osli bin Abd Razik, Associate Professor Dr. Margaret Chen Kit Yak and Dr. Ishak bin Anwar of University Technology Mara, Malaysia. Unit 3 is on sustainable groundwater and management practices. The topic covers the introduction of sustainable groundwater management practices, which are essential for preserving groundwater resources, which are a crucial source of fresh water for drinking, irrigation, and industrial use. Effective groundwater management involves a combination of strategies aimed at maintaining the balance between groundwater extraction and natural replenishment, monitoring groundwater quality, and preventing contamination. At the end of the course, students are able to identify the groundwater management, to explain the benefits of groundwater management, to recommend the integrated groundwater management. 6 subtopics are covered that include the introduction, aquifer recharge, groundwater management, sustainable extraction practices, benefits of groundwater management, and integrated groundwater management. Finally, we will put these concepts into practice by examining a detailed case study. Sustainable groundwater management practices are essential for preserving groundwater resources, which are a crucial source of fresh water for drinking, irrigation, and industrial use. Effective groundwater management involves a combination of strategies aimed at maintaining the balance between groundwater extraction and natural replenishment, monitoring groundwater quality, and preventing contamination. The 3 management practices are 1. Aquifer recharge, 2. Groundwater monitoring, and 3. Sustainable extraction practices. An aquifer is a body of porous rock or sediment saturated with groundwater, which is water that occurs in the subsurface. As shown in the diagram, groundwater enters an aquifer as precipitation and seeps through the soil. It can move through the aquifer and resurface through springs and wells. Aquifer recharge, also known as managed aquifer recharge or MAR, involves methods to increase the amount of water that infiltrates into groundwater aquifers. This is done naturally, but can be through engineered systems. There are 3 methods of aquifer recharge. Method number 1 can be by vegetation planting, which is establishing native plant species that are well adapted to local conditions. Method number 2 consists of zoning and land use policies that require implementing regulations on the establishment and maintenance of riparian buffers in new developments and agricultural areas. And method number 3 is through community engagement involving local communities in the creation and maintenance of riparian buffers through education and volunteer programs. As earlier mentioned, aquifer recharge is done naturally but can be through engineered systems. Let us look at how it works in natural and artificial recharge. In the natural recharge, enhancing infiltration is the creating or maintaining areas where water can naturally infiltrate into the ground, such as wetlands and riparian zones. Another natural phenomenon is through conservation tillage in agriculture using farming practices that enhance soil structure and increase infiltration rates. The artificial recharge can be implemented by 3 methods: by building recharge basins, injection wells, or infiltration galleries. Constructed basins for recharge at where surface water intentionally spread to infiltrate and recharge groundwater are often used during periods of high water availability. On the other hand, injection wells are drilled into aquifers to directly inject water, often used in urban areas where space for recharge basins is limited. The 3rd method is building infiltration galleries, which are subsurface structures that facilitate water infiltration into aquifers. The benefits of aquifer recharge pertains to 3 aspects. It helps balance groundwater extraction by replenishing aquifers. Infiltrating water can undergo natural filtration processes. improving its quality. Lastly, it prevents declines in groundwater levels, reducing the risk of land subsidence and maintaining flow to springs and streams. The second sustainable groundwater management is groundwater monitoring. Regular monitoring of groundwater levels, quality, and usage is critical for effective groundwater management. This involves collecting and analyzing data to make informed management decisions. What are the components that need to be monitored? 1. Water level monitoring. Installing observation wells specifically for monitoring groundwater levels across an aquifer to track changes over time. In addition, in practicing conservation tillage in agriculture, satellite or aerial imagery is used to estimate groundwater levels in large or inaccessible areas. 2. Water quality monitoring. Regularly collecting groundwater samples from various locations to test for contaminants such as nitrates, heavy metals, and pathogens. Continuous monitoring sensors are deployed in wells to provide real-time data on water quality parameters like pH, temperature, and conductivity. 3. Usage monitoring. Installing metering walls on extraction wells to measure the amount of water being pumped. Usage reporting is obtained by water users to report their extraction volumes regularly. There are 6 benefits derived from sustainable groundwater management practices. First, early identification of water quality issues allows for timely intervention to prevent further contamination. Second, monitoring data helps assess whether groundwater extraction is sustainable or if adjustments are needed. Third, data-driven decisions support the development and enforcement of groundwater management policies and regulations. Fourth, it ensures that groundwater extraction does not exceed the natural recharge capacity of the aquifer. Fifth, it maintains groundwater levels for future generations. Finally, it preserves the flow of groundwater-dependent ecosystems, such as wetlands and streams, that rely on stable groundwater levels. The third sustainable groundwater management is sustainable extraction practices aimed to balance groundwater withdrawal with natural recharge rates, preventing overexploitation and ensuring long-term availability of groundwater resources. There are a number of green extraction technologies that include those listed in the diagram, like better isolation, reducing energy consumption, using alternative solvents, adopting renewable natural products, using high-quality extract, more selectivity, using safe products, and using low environmental impact methods or products. 3 key practices adopted are regulated pumping, use of water-efficient technologies, and engaged demand management. In regulated pumping based on permits and quotas, implementing a permit system limits the amount of groundwater that can be extracted based on sustainable yield assessments. In addition, adopting conservation tillage in agriculture, groundwater extraction should be limited during dry seasons or drought periods to protect water levels. There are 2 prominent water-efficient technologies, namely efficient irrigation system and industrial water recycling. Efficient irrigation systems use drip irrigation, sprinkler systems, and other water-efficient technologies to reduce groundwater use in agriculture. Industrial water recycling has systems to recycle and reuse water within industrial processes, reducing the need for fresh groundwater extraction. The last key practice is demand management. This is through public awareness campaigns educating the public and stakeholders about the importance of groundwater conservation and efficient water use practices. In addition, incentive programs can be offered with financial incentives for adopting water-saving technologies and practices. Effective groundwater management often requires an integrated approach that combines all the 3 sustainable groundwater management practices: aquifer recharge, monitoring, and sustainable extraction practices with broader water resource management strategies. This includes watershed management, land use planning, and policy and governance. Watershed management is coordinating groundwater management with surface water management within a watershed to ensure holistic water resource sustainability as shown in the diagram. Integrating groundwater considerations into land use planning to protect recharge areas and prevent activities that could contaminate groundwater. Finally, it needs robust policies and governance with regulatory frameworks that support sustainable groundwater management, enforce regulations, and involve stakeholders in decision-making processes. Let's dive into our practical application with the case study titled Restoring Balance, Addressing Groundwater Depletion and Contamination in a Growing Smart City. The background: our scenario focuses on Aquatech Metropolis, a rapidly developing city that relies heavily on its local aquifers for its urban water supply. Unfortunately, recent rapid industrial expansion and new residential zoning have taken a significant toll on the city's natural resources. The challenge: the city's water utility department is facing a critical problem regarding the strategic integration of their water systems. Specifically, they must address a severe imbalance between groundwater extraction and its natural replenishment. Continuing with our case study, we need to look at the direct impacts of these problems. The current imbalance in the water system is leading to severe contamination and resource loss. New surface activities brought on by the recent developments are actively polluting the city's vital recharge areas. To make matters worse, the local government is making uninformed management decisions because they have insufficient data regarding the actual health of the aquifer. This brings us to your assignment for this unit. You will step into the role of a smart city water management consultant. Your task is to draft a strategic proposal to resolve the crisis in Aquatech Metropolis. Your proposal must successfully address the following two areas: integrated management plan. You must detail how you will adopt integrated groundwater management. Specifically, you need to coordinate land use planning and watershed management to protect the city's vulnerable recharge areas. Data and monitoring strategy. You must outline a plan to implement regular groundwater monitoring. This strategy should be designed to support the City Council in making informed policy and governance decisions. At this juncture, we have completed Unit 3. It is time for self-reflection. Please do not forget to take the quiz.